Bright Duty. Every student matters.
The stars. Till now you have learnt about the moon. Now we are on to the second topic, that is the stars. We discussed that in the night sky the brightest object was moon, and the second brightest are the stars. Right? They are very shiny. They have their own light. Stars have their own light. They do not shine due to the light of other stars. They shine because of the presence of their own light, like the star, the sun, that is in our solar system as well, which is the nearest star to us, which is 8 light years away. We will be studying what light years are and why we measure this distance in light years. Now students, stars emit light of their own. We are discussing some facts about stars here. Interesting facts. Stars have their own light as I told you. The sun is also a star. The stars are millions of times farther away from the sun. The sun is the nearest star. The other stars are much farther away from us. The sun is nearly 150,000,000 kilometers. It is 150 million kilometers in distance. Basically, if we measure it in kilometers, it will be 150 million kilometers. Now, the next nearest star is Proxima Centauri. It is a distance of about, you can see the number of zeros present here. It is the double amount of that of Earth. So, you can imagine how far the Proxima Centauri is. Kilometers from Earth. 40 and then add 12 zeros to it. It is a very long distance in kilometers. Such large distances are expressed in another unit known as a light year. Right? It is the distance travelled by light in 1 year. Now students, the speed of light is 3.8 into 10 to the power 3.0 into 10 to the power 8 meter per second. So you can understand, in 1 second light travels so much of a distance, right? This is the distance travelled by light in 1 second. In 1 year, you can imagine the kind of distance that light can cover, right? It is the distance travelled by light in 1 year. The speed of light is about 3 lakh kilometers per second. The light travels at the speed of 3 lakh kilometers per second. Now, in 1 second, it covers 3 lakhs. In 1 minute, what is the distance covered will be 3 into 60, that is 180 lakh kilometers. In 1 minute, the light covers 180 lakh kilometers. Can you write it in distance? 180 and then 5 zeros. This is the distance covered by light in 1 minute, right? Now students, the distance of the sun from the earth may be said to be about 8 light minutes. As we know now, this is 180, 00 then 000 kilometers is the distance travelled by light in 1 minute. 1 minute. Right? Now in 8 minutes, what is the distance travelled? We multiply this amount with 8 and we obtain the distance that is about the distance of Earth from the sun. This is the distance between the Earth and the sun, and this is the nearest star. Right? Now the distance of Alpha Centauri is about 4.3 light years. Now we were discussing about only 8 light minutes, and this was a huge distance. When we talk about light years, it is a distance that you cannot even imagine. It is so big a distance. You can calculate this distance 4.3 light years for yourself, and you will be obtaining what kind of distance this is, how many zeros you will be able to add. You will have to add to obtain the distance between our planet Earth and the Alpha Centauri. You should calculate this. You will be able to get to know what is the kind of distance that we have in our celestial objects. Now students, what happens to the stars in the day? Stars are present in the sky, so we must be able to look at the stars in the daytime as well. But the stars are present in the sky during the daytime. They do not disappear. They are just not visible to us then, because, why are they not visible to us? Because of the bright sunlight. This is the reason why we are not able to look at the stars in the daytime, because of the bright sunlight. Sometimes if you look very carefully during evening, 5 to 6 p.m., you will be able to look at some of the stars because they have very bright light, right? Only some of the stars will be visible to you. during the sunset. Observe some prominent star or a group of stars in the sky for about 2 hours or more, right? The stars appear to move from east to west. From east to west, they appear to move from east to west. This is because the earth moves from west to east. This is a simple experiment, students. For example, this is a glass, right? And this is an object. If the glass moves from west to east, right? The glass, if we stand on the glass, we will be seeing that this object is moving from east to west. If this moves from here to here, this will appear to be moving this to here, right? Let us see what is happening here. This is the motion that is actually happening. That is not actually happening. Only this is happening. But the object, the person standing on the glass will see that this is moving from here to here, while the actual motion is this. The person standing on the glass will feel the motion as this object is moving while the planet is not moving. So this is the phenomenon. The star appears to move from east to west. A star which rises in the east in the evening sets in the west in the early morning. If this is the star you saw in the daytime, night time here. Now in the morning, it will be setting here. Morning. And then it will become invisible. Basically, this is the movement of the star and this is our planet Earth. Our planet is revolving in this direction, west to east. This is the rotation of Earth on its own axis, due to which we feel that the other objects are moving in the opposite direction. Right? Now, can you understand what I am talking about? If you move your head from this to this, you will be observing that the objects present around you are moving in the opposite direction. This happens. The sun appears to rise in the east and set in the west. The sun appears to rise in the east. Here is the sun, right? And it sets in the west. Again, the same concept. This is the planet Earth. It is revolving in this direction, and hence we see that the sun is moving in the opposite direction, right? Stand in the center of a big room and start rotating. Which direction will the objects in the room appear to move? Just the opposite. If you are moving anti-clockwise, then the objects will move clockwise. This is the basic observation. If you see that sun rises in the east and sets into the west, then the movement of Earth is actually, Earth rotates from west to east. Earth is rotating from west to east. Right, students? All about stars. In the next lecture, you will be studying about constellations. Constellations. Now, what is a constellation, students? Here is a picture in front of you in which you can see different groups of stars making different patterns. Like this is Capella. Capella is a star. This is the Auriga constellation. Auriga. Right. This is the Ursa Major. This is Lynx. This is Bootes. This is Corona Borealis. This is Hercules. This is Lyra. This is Draco. This is Ursa Minor. This is, what is this? Camelopardalis. This is Cassiopeia, and this is Ceneus. So these are all basically different combinations. Now what is the combination of Lynx? This is the combination of Lynx. This is the composition of Ursa Major. Combination basically. This is for Bootes. This is Corona Borealis. This is Hercules. This is Lyra. This is Cepheus. This is Cepheus. This is Draco. And this is Cassiopeia. Basically, you have seen a number of combinations now. Now, let us start what a constellation is. The stars forming a group that has a recognizable shape is called as constellation. Constellation is basically a group of stars which makes a recognizable shape. For example, you will be seeing different kinds of examples in this lecture, what a constellation looks like. These were devised by ancient people. The shapes of constellations resemble objects familiar to those people. The names have been given by those people. They whatever they thought was similar to those shapes, they gave the name to that shape, right? Let us start with some common constellations. When you look at the night sky, you will be able to look at some combinations of some stars. These combinations are known as constellations, and they are present as the same at every night, right? Now, some common constellations. Let us start with some common constellation. The first one being Ursa Major. Now, students, Ursa Major appears like a big ladle or a question mark. As you can look at this picture, this is what a ladle is, right? There are 3 stars on the handle of the ladle. 1, 2 and 3. These are on the handle, right? And 4 on its bowl. 1, 2, 3 and 4 are on its bowl. Right. In ancient cultures, very interesting mythological stories have been associated with the various constellations. There are various constellations which have some interesting stories linked to them. Dipper used for drinking water in ancient times. This is basically an apparatus used for drinking water and also named as a dipper. This is the shape of the constellation, like the dipper, right? Now, it can be seen during summertime in the early part of the night. Ursa Major basically can be seen in the summertime, in the early part of the night, like 7-8ish time. It is also known as the Big Dipper, the Great Bear, or the Saptarishi. These are the names that have been given to Ursa Major. The Big Dipper, the Great Bear, or the Saptarishi, because it has been named after 7 rishis of Indian mythology. There are 7 prominent stars in the constellation. Let us see what they are. Saptarishi has been associated with 7 well-known ancient Indian sages or rishis. As shown in the figure below, you can look at the picture. Marichi, Vashisht, Angiras, Atri, Kratu, Pulaha, Pulyastya. Right? These are the names of 7 sages. According to ancient mythology, the 7 sages who formed the Saptarishi preserve the eternal knowledge of Vedas and explain it to the people every new age. This is the myth behind this whole Ursa Major concept. This is basically the shape. Now you can clearly look at the shape. This is the first star, this is second star, this is third star, fourth star, fifth star, sixth star and seventh star. Right? Let us mark this constellation. This is the Ursa Major, which is known as the Big Dipper, Great Bear and Saptarishi as well. It is formed with the help of 7 stars in the form of a ladle. 3 stars are present at the handle, while 4 stars are present at the bowl as a quadrilateral. And according to Indian mythology, these 7 stars are named after the 7 sages of Indian mythology, right? Now, does a constellation change its shape? Can you think of a constellation changing its shape? The shape of the constellation remains the same. Now again, let us move back to the rotation of Earth. This is basically the ladle right now, and this is the bowl. This is the Saptarishi constellation or the Ursa Major constellation. This is the constellation, and this is the surface of the Earth. Right? Imagine you are present here somewhere. Firstly, you are present here. Now the Earth is rotating from west to east. Right? This is the west. The Earth rotates from west to east. Now what is happening? You ultimately will reach, you are present at point A. You will reach point B after some time. Right? Now this constellation which was present here earlier, what is happening basically? The Earth is rotating. You are moving. But what happens is, you imagine that now the constellation has moved backwards. It has changed its position. Actually, what is happening is the stars are constant, but you are moving on the surface of the Earth. For example, let me erase this constellation from here. Right? I'll be drawing it at such a position that you will be able to understand what I'm asking to you, what I'm asking you to understand basically. Now, here is the constellation. Right, students? This is the constellation. You are standing here, you are able to look at it directly. Then after some time the Earth rotates and you reach this point. right? The orientation has changed, you are at a different angle. Now what you think is the Ursa Major is present here. According to you, it still should be here above your head, but it is not above your head, it has moved here. It means that according to you, the position of Ursa Major has changed, but it does not change, but only Earth rotates, which makes us think that the constellation is moving. It appears to move in the sky from east to west, right? Here it was above your head, now it has moved to your left. So it means that it is moving from east to west according to you. But what actually is happening, that you are moving from west to east, and hence you think that the other objects in the sky are moving in the opposite direction, right? Now we have some important observations. On a clear moonless night during summer at about 9 p.m, you have, for example, on 23rd June, the longest day of the year, go on your terrace and look at the two stars at the end of the Ursa Major. This is the constellation, and these are the two stars at the end of the Ursa Major, right? Imagine a straight line passing through these. This is the straight line passing through these, right? Extend this imaginary line towards the north direction. This is the north, and you have extended this line towards the north, right? This line will lead to a star which is not too bright. This is the pole star. This is the pole star, right? It does not move at all as other stars drift from east to west. What are we talking about here? We see constellations also change their positions, other stars change their positions, but the pole star never changes its position. Why? The motion of Earth is still going on. It should also change its position, but it does not. Let us see why. Basically, the pole star is present at the axis of our planet Earth. Let us see what is happening here. This is our planet Earth, and this is the axis of the planet Earth. Now the pole star is present somewhere here. Now if the Earth keeps on rotating, the other stars will change their position because they are not at the axis of the Earth, but this is on the axis of the Earth. So whatever point you are, it will always be at the same position on the axis of the Earth, right? Earth's center is not moving with respect to the pole star, so the pole star always appears to be at the same position with respect to the surface of the Earth, right? So now you have understood what is the concept and where the pole star is located. Pole star is at the perpendicular drawn from the axis. If we draw the axis further into the sky, we will obtain the pole star, which means that pole star is present on the extended axis of our planet Earth. Hence, it never is seen to be moving. Now, during the summer night, observe Ursa Major 3-4 times at an interval of 2 to 3 hours. You have to observe the Ursa Major for approximately 2 to 3 hours. Also, locate the pole star each time. You have to locate the Ursa Major and the pole star. All the stars appear to revolve around the pole star. What is the observation that you do? This is the time, basically, you can say 6 p.m. right? Then this is 8 p.m. Then this is 10 p.m. and this is 12. Basically, this is midnight. You can assume 2 hours gap in all the positions. What is happening? This is the position of Ursa Major, and this is the position of the pole star. Then after 2 hours, Ursa Major reaches here. The pole star is still here. The Ursa Major now after 2 hours has reached this position, while the pole star is still at that position only, and the fourth time, which is the 12 p.m., which is the midnight, 00 hours basically. At this time also pole star is fixed while the Ursa Major has changed its position. It appears that the Ursa Major is rotating, is revolving around the pole star as its center, right? Pole star is not visible from the southern hemisphere. Pole star cannot be seen from southern hemisphere because it is present on the north pole, basically on the north axis. This is the north part of the Earth. Here is the pole star. So only the upper hemisphere will be able to look at the pole star. The southern hemisphere will not be able to look at the pole star. Some of the northern constellations like Ursa Major may not be visible from some points in the southern hemisphere. There are some parts in the southern hemisphere of our planet from which we cannot look at the Ursa Major. Moving on to the next constellation, that is Orion. Now students, Orion can be seen during winter in the late evenings, which is around 6 to 7 p.m. Right? In the late evenings, you can look at the winter sky, you can observe Orion. Now what is happening? Orion can be seen during winter sky in late evenings. It has 7 to 8 bright stars in itself. This is basically Orion and it has 7 to 8 stars. 3, 4, 5, 6, 7, 8. Right? Also called the hunter. We call this orientation as hunter as well. The 3 middle stars represent the belt of the hunter. This is the belt of the hunter. There are present 3 stars, 1, 2 and 3. Right? The 4 bright stars appear to be arranged in the form of a quadrilateral. The 4 stars appear to be present as a quadrilateral. The star Sirius, which is the brightest star in the sky, is located close to Orion. This is the brightest star. And it is located close to the Orion. This is very close. To locate Sirius, imagine a straight line passing through the 3 middle stars of the Orion. These are the 3 middle stars. If we draw a straight line combining them and we extend it into the atmosphere, it basically reaches towards the Sirius, which is the brightest star in the sky. This line would lead us to a very bright star, that is Sirius. So this is another constellation that is named Orion. It has 7 to 8 stars. It has been named Hunter. It has 3 stars in the middle and other 4-5 stars arranged as a quadrilateral. If we combine the 3 stars present in the middle and draw a straight line passing through them and we extend it into the atmosphere, we reach a star, that is Sirius, which is the brightest star in the sky. So this was all about the Orion constellation. Next is Cassiopeia. What is Cassiopeia? It is another prominent constellation in the northern sky. It is visible during winter in the early part of the night. Again, we see Orion in the winters as well. We see Cassiopeia in the winters as well. Orion is seen in late evenings. Cassiopeia is seen in early nights, almost during the same time. Looks like a distorted W or M. Let us see. This looks like a distorted W or M. There are 1, 2, 3, 4 and 5 stars present in this constellation. Right? So this was all about Cassiopeia. A constellation, basically, let us discuss some facts about constellations again. A constellation has a large number of stars. We see only the bright stars in the constellation with our naked eye. A constellation is not only made up of 7-8 stars. It has hundreds of stars present inside it. We are only able to look at the brightest stars. And that is helpful to us, so we only consider the brightest stars. As you can see in this picture, there are a lot many stars present in the background. But only 1, 2, 3, 4, 5, 6, 7 and 8 stars are bright. This is the picture of, again, which constellation? Orion. Right? Now, we are only able to look at these 8 bright stars. Hence, we think that it is only made up of these 8 stars, but it is not so. It is made up of so many stars which are not clearly visible to us. If you look at it carefully, there is a shape of a warrior drawn behind it. Right? With a shield, with a weapon. So, this is the whole shape actually. Right? All the stars which make up a constellation are not at the same distance. They are not even in the same plane or at the same distance. They are just in the same line of the sight in the sky. They are in the same line of sight. For example, if we see this star, there is a star just behind it, then star just behind it. So, we only see some stars which are very bright and present in the front of us. We are not able to see the stars which are less bright and are present behind these stars. So, this is about constellation, students.